In this lesson, we're going to do two quick problems relating some of the trig information. I want you to find sine of theta given that cosecant is equal to a root 8 over 2. I know that I can simplify the root 8, but I'm going to worry about that here in a second. It's basically just the idea that cosecant is the reciprocal of sine. So if cosecant is going to equal this, that's telling me that sine is going to equal the reciprocal of that, which is this. However, I got to do a little bit of cleaning up here. So I want to rationalize the denominator, which means I'm going to multiply the top and the bottom by another square root of 8. The reason that that is okay, because technically this value is 1, and you're multiplying a fraction by 1, which doesn't change the value, it's just going to change the look. So you have a 2 root 8 over 8. The reason that that becomes 8 is because that turns into a square root of 64. That was the whole goal, is to not have a square root on the bottom. So we multiplied it by itself, which created a perfect square, and we squared it to get an 8. So we have some simplifying that we got to do here. The square root of 8 we can break into a square root of 4 and a square root of 2. The 2 and the 8, I can simplify that, the 2 out of both of those. That'll become a 1 and a 4. So now I'm sitting with 8 broken into 4 and 2 because this is a perfect square, and the denominator so far is simplified to a 4. This becomes 2. So you're looking at 2 root 2 over 4. And then that becomes 1, that becomes a 2. So final answer eventually here is square root of 2 over 2. So that is quite a few little steps just because of the fact that when we did the reciprocal, that turned the denominator into that. So one other problem is we're going to do a similar question where we're going to find a secant of theta given cosine, its reciprocal, is equal to 3 over 2. So try to figure out what secant is given that cosine is 3 over 2. Well, strangely, this is not possible. Alright, so what happened? This is the problem. That's not even a true statement. Sine and cosine is limited. So the output that you get, so sine of theta equals some value. That value has a range, and that range is between a -1 and a +1. So you can throw in any kind of angle you want, but it's going to fluctuate between a -1 and a +1. It won't get bigger and it won't get smaller than that. So there's no possible way to have 3 halves, because 3 halves is bigger than 1. So if that's not possible, then we're definitely not going to be able to do any kind of reciprocal for it. Cosine, whatever output that you get out of that, also ranges between a -1 and a 1. I put brackets around both of these because you could hit the -1. That represents that we're including -1. And tangents, what outputs you get out of here is, surprisingly, tangent can be anything. It can go from a -infinity to a +infinity. And when you graph these, you'll have some visual representations to kind of show you that a sine curve kind of fluctuates between a -1 and +1, so same thing with a cosine, but a tangent is something that goes up and down forever. So it hits every possible y value. So not everything's going to have an answer, so you can't get past the first piece of information that's not even a true thing. So that's using a little bit of some of the trig definitions.